Hello everyone, I am Pradnya. In this video, we are going to study chapter 4, Introduction to Problem Solving. This chapter includes the steps to solve a problem and the different tools to design a solution for the problem like algorithm, flowchart and Pseudocode. So let's get started. The first topic is the problem solving cycle. We use computers to solve a real life problems. So to program computer, we should use efficient problem solving techniques. Problem solving methods follows a cycle. It is known as problem solving cycle. It has four main steps. For the first step is analyze the problem. First we have to understand the problem, analyze the problem. Then we have to find the appropriate solution for it. This is the second step. And we have to write the algorithm to solve the problem. After writing algorithm, we have to write the program using some programming language. This is the third step. In the fourth step, we have to find out the errors and rectify the errors, that is called as testing and debugging. Each of these four main steps has some sub-steps. So let's study it in detail. The first step is understand the problem. If you want to solve any problem, first you have to understand the problem well, because sometimes the things may not be same as it seems. After understanding the problem, analyze the problem properly. In that we have to find out what are the inputs and what are the processing components. This is also one of the important steps, because the success of the solution depends on the analysis. After analyzing the problem very well, design the solution. In designing the solution, we write the step-by-step solution and decompose the solution. Decompose means breaking down the main problem into the sub-problems so that it is easy to find out the solution for it. After finding out the best solution for that problem, we have to code the program. In coding, we have to identify what are the arithmetic and logical operations, and we have to choose the appropriate control structures that we are going to study in the coming chapters. When you finish writing the program, we have to test the program, means we have to find out the errors. And after finding out the errors, we have to rectify the errors. It is called as debugging the program. The next step is complete the documentation. It is a detailed description of the program which helps the other users and the programmer to understand the program. And the last step is maintain the program, means to keep your program up to date or remove any previously undetected errors. So these are the total 7 steps to find out the solution for any problem. The next topic is problem solving using decomposition. What is the decomposition? It is a process of breaking down the big problem into the smaller problems. Look at this diagram. What we are doing here, we have a big problem that we are breaking down into a smaller part 1 and part 2. And the part 1 of the problem, again we are breaking down into the sub problems. This technique of decomposition we use in everyday life. Let's take one example. If you want to host a birthday party, you use decomposition technique to select menu, to decide the time, to identify the venue, and task people what they have to bring. Let's take one more example related to computer science. Suppose if you want to design any video game like Minecraft, you use decomposition technique to divide the work like game design, programming, art, video. Then this would make it easy for you to make the team and assign the work to them. So in this way, decomposition helps to solve the problem by breaking down the big problem into smaller one. Now let's try to understand what is algorithm. Algorithm is a set of steps to solve a particular problem. Algorithm is one of the tools to solve a problem. So what are the characteristics of an algorithm? The first one is precision. All the steps what we are writing in the algorithm should be precisely defined. The second characteristic is uniqueness. The result of each step or the outcome of each step should be unique. It should not be ambiguous. The third characteristic is finiteness. Algorithm must stop after a finite number of steps, because we need short and accurate solution for the problem. The fourth characteristic is input. Algorithm should accept input because to produce the output, we are working on some input. And the final characteristic of an algorithm is the output. So algorithm should produce the required output. And input, process, output is the main components of the algorithm. You know, computer also work on this principle of IPU, that is input, process and output, and similarly algorithm also works on this principle. So these are some of the components and the characteristics of an algorithm. How to write an algorithm, that we will study in this video. So let's proceed with the next topic, that is flowchart. So what is flowchart? It is a pictorial representation of the step. So we are using some symbols to represent the solution. Let's look at the some of the symbols used to draw the flowchart. The first one is the oval. It is used for start and stop. The next symbol is parallelogram. It is used to take input and output. The third one is a rectangle. Rectangle is used to represent processing. If you are taking some decisions in the program, then it is represented by the decision box, which is represented by diamond, or you can call rhombus also. Then there is a flow of information, which is represented by the arrow symbol. There is one more symbol, it is used for annotation. And we have connector. If your flowchart cannot fit in one paper, we can continue on the next one also using the connector. So let's try to understand with one example how to write an algorithm and how to draw a flowchart. Here we have to write an algorithm and draw a flowchart to add two numbers. Whenever you are solving any problem, first identify what is input, what will be the processing, and what is our output. So here we need to add two numbers. So first we need two numbers. Let's imagine that I am taking 10 and 20. Then we have to add this 10 and 20. It is processing, and the output will be the result of it, that is 30. To store numbers we need variables. So let's take two variables A, B, and the result of this processing also we should store in some variables. So let's take variable C to store the result. And the next step, we have to display the output. For that we will use print statement to display, and our result is in the variable C, so we will print C. So let's write the algorithm to add two numbers. Always the step 1 will be start and the last step will be stop. Then in the next step we have to write what we need input. So for that you can write input, and the variable name you can take anything. We will learn in Python how to take these variable names. And the third step is processing. So C is equals to A plus B. After processing we need to print the output. So step 4 will be print result. So we are storing the result in the variable C. So we got the output. Now fifth step will be stop. In this way you can write the algorithm. It's very easy. Now it's turn to draw the flowchart. So follow these steps to draw the flowchart. First step is start. For start we have to take the symbol oval. So write the instruction into the symbol. So start. For input, you know, for input and output we have to take the parallelogram. So draw it and write the instruction inside it. Input A, comma B. Now proceed. Next step is the processing. For processing we need to take rectangle. So the statement is C is equals to A plus B. Now we have to print the result. So for that also we have parallelogram. So write the instruction here, print C, and the last step is stop. For start and stop we have to use oval shape. So in this way we wrote the algorithm and we drew the flowchart also. So let's take one more example. Here we have to write the algorithm and draw the flowchart to calculate area and perimeter of the rectangle. If you are a math student, you know the formula to calculate the area of rectangle. So area is equals to length into breadth, and the perimeter is equals to twice L plus B. To solve any problem, always identify what is the input, what is processing, and what will be the output. To calculate area and perimeter of the rectangle, we need length and breadth. So I am taking L for length and B for breadth. So this is our input, and processing will be, we have to calculate area and perimeter, and the output we have to print again area and perimeter. So let's write the algorithm for it. Always the step 1 will be start. In step 2 we have to write the input. So our input is length and breadth, so L and B. After taking input, the step 3 will be processing part. So here we are calculating area, so write the formula here. In the same step I am calculating the perimeter also, so I am taking variable P for that, and this is the formula for perimeter. After calculation, the next step is display the result. So we will print here area and perimeter. You should take the same variable name what we have taken in the processing step. So the last step will be stop. So step number 5 will be stop. Now look at the steps in the algorithm and try to draw the flowchart. The first step is start. For that we take the oval symbol. For input we need to take the parallelogram and write the instruction into it. Input L, B. The next step is the processing step. For that we need rectangle. So the first formula we have to write in the processing is area, and the second is perimeter. So write down the formula for it. After calculation we have to print the result. For that again we need to take parallelogram. So print area, and we have taken variable P for perimeter, so I am writing P here. And the last step we have stop. So for that I am using oval. There are many examples in your textbook. Try to solve each and every one if you are interested in programming and if you want to pursue the higher study in computer science. It is very interesting. If you will understand the concept now, you can learn any programming language in future. These two examples were very simple, in which all the steps were executing from first step to the last step. Now let's consider one more example based on the decision making, where we are using one condition, and based on the condition some statement will execute and some will not execute. So let's take one more example in which we have to find the larger of two numbers. So first identify the input. We need two numbers here. Then what's the processing? Here processing means we have to compare these two numbers. So we need some conditional statements, and the output will be, we have to print the larger of that. Let's try to write the algorithm for it. Always the step 1 will be start, and in step 2 generally we take the input. So here I am taking input two variables because we have to compare the two numbers and we have to find out the larger one. In step 3 now I have to compare these two variables. So for that we will use some comparisons operator that we have studied in maths in the lower grades also. To compare two numbers we have one statement if. So if A is greater than B. If is a conditional statement which will give only two output, yes or no. If it is yes, we will have some statements. If it is no, we will have another set of statements, and any one of that will get executed based on the condition. So look at that if statement. If A is greater than B, if this statement is true means you will get S. Then A is greater than B means you are getting A is larger. So accordingly you can print the message that the variable A is larger. Then what about if this statement is not true? Then it will execute N, that is false statements, means A is not larger than B means what? The B will be larger. So accordingly else part we can write, else part is the false part, or we can say if it is executed to no or false. So then in that case if A is not greater than B means B is greater, or we can say B is larger. So we can print the message accordingly. So based on the condition either this statement will execute or this statement will execute. So we processed and we got the result also. Now the last step we have to write, that is stop. So in this way we have written the algorithm. Now let's try to draw the flowchart for it. The first we have to draw oval for start, and the next step is input. So for input we need to take a parallelogram. So this is the parallelogram. Okay, now we need to take the decision. For decision making we have the symbol rhombus. It is known as decision box. So we can draw it. We have to write here condition is A is greater than B. For a conditional statement always you will get two options, yes or no, or we can write it as a true, and for no we can write as a false. So this decision box also has two options. We can write yes and we can write no. Okay, this side I am writing the yes part, this side I am writing the no part. Even you can write T and F also. If A is greater than B, we have to write this statement. If A is greater than B means what? We have to print the message that A is larger. You can use printf statement here also. Print A is larger. And for output we need parallelogram. So you can draw it like this. And for no, this is our else part, that is no part. Here we are printing B is larger. So you can print the message here. After printing the required message, we need to stop this. So from both these options, we have to go to the next step, that is the stop. So for decision making, you have to draw the flow chart in this way. Here, based on the condition, either one set of statement will execute or the another set of statement will execute, but not both. Okay, let's take one more example based on the decision making. Here we have to check the number is even or odd. You know how to find out the number is even or odd. The number which is completely divisible by 2 is even number, otherwise it will be odd number. And for finding out the remainder, we use modulus operator. If any number is completely divisible by 2 means if modulus is equals to 0 means it is an even number, or it will be odd number. Modulus operator gives us the remainder. So let's try to write the algorithm for it. So the step 1 will be start. In step 2 we have to take one number. So input statement I am using for that, take any variable. I am taking variable n. Now in step 3 we have to find out whether it is an even number or odd. For that I am using if statement. If n modulus 2 is equals to 0 means this number n is completely divisible by 2. That's why we are getting this remainder 0. If it is completely divisible by 2 means it is an even number. So we can print the number is even. If it is not completely divisible means it is a odd number. So you can write in the else part is the false part. If this statement is not true, the control will come to the else part. In that we are printing that number is odd. So after if we will get the true part, and else part is the false part of that conditional statement. After printing the result, we have to stop the algorithm. So last step will be stop. Now try to draw the flowchart for it. The first step is start. So we will use oval for that. The next step we have to take the inputs. In the next step we have to check that number is completely divisible by 2 or not. For that we are using rhombus. If it is true you can write T also, yes also, and for false you can write F or no. So true part means what? If number is completely divisible by 2, so we can print the message the number is even, and for output we use parallelogram. In the same way we can print the message here that this number is odd if the statement is false. After printing the message, we should stop this program or algorithm. So we need to write the last step as stop. For that we are using oval. Till now we studied two types of algorithm and flowchart. The first one was the simple one where all the statements were getting executed. The second one is using conditional statements where depending on the conditions one set of statement were executing and one set of statement were not executing. And there is one more concept that we have to understand, that is looping. That looping means certain statements will execute repeatedly for a specific number of times. So how to draw the flowchart for it, now we have to understand that. In this what we have to do, we have to print the numbers from 1 to 10. So let's try to understand how to write the algorithm for it. Always the step 1 will be start. Now what we have to do, we have to take the number from 1 and it should proceed till 10. So in the step 2, for that I am using one looping statement. It is called as for all. The looping statements we will study in the Python. For now just keep in mind that there is one looping statement for to repeat the statements for a fixed number of times. So for I is equals to 1 to 10, we have to specify the starting number and we have to specify the last number. And the same number we have to print also. So I am going to print here I. So each value of I will get printed. After printing we are not doing any processing here. So the last step will be stop. Now let's try to draw the flowchart for it. So first step is start. So we are using oval shape for that. And then we have to design this loop. So how to design this loop? First we are initializing the value 1 to the variable. So initialization statement is also a processing statement. That's why I am writing it into the rectangle. Now next we have to check whether this I is less than or equal to 10, because we have to execute this loop only till 10. The value should not go beyond that. That's why I have to check is this I is less than or equal to 10. If this loop satisfied, the control will come inside the loop and this statement will execute. In this statement we are printing the value of I. So the print statement I am using, and this is the output statement. So for that I am using parallelogram. What if it is not true? If it is not true, it should stop. So the false part I am going to write here. After that I am writing the stop statement here using the oval shape. Let's come to this true part. After printing the value once, we should repeat these statements again and again for 10 times, because we have to print the values from 1 to 10. In the beginning we had only value 1, it got printed, but it should proceed to the next value also. So we have to increment the value by 1, because in for loop by default it will increase by 1. If it is increased by 1, again this is a processing statement, so we are using rectangle box. After incrementing also we should check that whether it is less than equal to 10 or not. So again this control will go to the check statement and it will try to find out whether it is less than equal to 10 or not. So the next time the value of the I will be 2. Again it will get checked. If it is true, it will get printed. Again next time the value of the I will be 3. Again it will get checked whether it is less than equal to 10 or not. If yes, it will get printed. In the same way it will execute till 10. When it is reached to 10, it will get printed and the value will get increased by 1. It will become 11. When it will get checked here, this condition will not satisfied because it is 11. It is greater than 10. Then the no part will execute and the program will stop. In this way, we will print the values from 1 to 10. So this is one of the example of looping statement where the statements are repeating for a specific number of times. It's the high time for you all to think like a programmer. If you will get used to it, how to solve the problem, it will be very easy to solve the complex problem later. Based on the looping concept, one more example I am going to consider so that you will understand how to draw the flowchart for the loops. Here we need to calculate the sum of the n number. Sum of the n numbers means we have to calculate 1 plus 2 plus 3 plus 4 and so on up to n. So we can decide how many number of terms we have to calculate. And this sum we have to print it. I am going to initialize this term to one variable sum. Now let's try to find out how to write the algorithm and how to draw the flowchart for it. Always the first step will be start. In the next step we have to take n, that is input n, because we have to decide how many number of terms we have to take or how many numbers we have to add it here. In the step 3 I am taking one variable sum and initializing it to 0. So in the beginning sum will be 0 and later we will keep on adding each number to it. Okay, let's design the next step. The step 4 will be for loop. For I am taking one variable I to move from the first number till the last number. So the value will be 1 to n. So we are starting with 1 and we will go up to n numbers that we are getting input. Now we have to add each and every number. So for that I am writing one statement, sum equals to sum plus I. So initially the sum was 0 and the first time the value of the I will be 1 and it will get added. Next time the value will be 2, it will get added and it will go up to 10. To make it simple, I am considering the value of n is 10. Here we should write one more statement, that is next I, so that it will go to the next value of the I. After calculating the sum, we don't have to print each and every term here. Only final answer we have to print, that final sum what we are getting we have to print. So in the step 5 we have to print the value of the sum what we got. And the last step will be stop. Now let's draw the flowchart for it. The first step is start, so oval for that. The next step is input statement, so we use parallelogram for taking input. And in the next step it is a processing step, sum equals to 0, so we are using rectangle. And now we have to design the for loop. So the first value of I is equals to 1. That's why it's a processing statement. We are using rectangle. Now we have to use the decision box that to check that the value of I is less than equals to n or not. If it is less than equal to n, we will keep on adding. So if it is yes, we have to use the processing statement, that sum equals to sum plus I. After adding the value, again we have to increment the value. So by default the value of I will get incremented by 1, and then we will check that whether it is less than equals to n or not. If it is less than n, we will keep on adding. But if it is greater than n, it should not get added. So finally after calculation we are printing the value of the sum. So we are using this print sum and printing the value of it. After printing it we need to stop it. So I am going to use the oval shape to stop. In this way we have written the algorithm and we drew the flowchart. Okay, let me explain how this program is getting executed. The value of the sum is initially 0 and the I varies from 1 to n. So initially the value of I is 1. Now we are adding it to the sum. So the initial value is 0. Now we are adding 1 to it. So we got 1. Now the next time the value of I will get increased by 1. It will be 2. Now add it again to the sum. The sum is now 1 and add the 2 to it, it will be 3. After incrementing the value of I, it will be 3. Now the previous value of sum is 3 and we are adding 3 to it, it will become 6. The next value of I is 4, it will go till 10, or you can just consider instead of 10 consider the value 5. Now the initial value of the sum is 6. We are adding 4 to it, it becomes 10. The next value of I will become 5, and again the initial value of sum is 10 and we are adding 5 to it, it will be 15. So you can see here, if we add 1, 2, 3, 4, 5, we will get value 15. So our program is correct. If we add manually also we are getting 15, and I have shown you how this is getting calculated using program. So there also we are getting value 15. Till now we studied the two tools, that is algorithm and flowchart, to find out the solution for a particular problem. There is a one more way, it is called as pseudocode, to write the solution for the problem. What is pseudocode? It's an informal way of describing the steps. Here also we are writing the steps like algorithm to solve a problem, but there are no rules. We can write the way we want using pen and paper, even in our local language. So what are the advantages of pseudocode? It uses the plain English language. As we are studying in English, that's why we are writing in English, otherwise you can use your language also. It highlights the sequence of algorithm. Pseudocode is a way to write an algorithm, because first we can write the pseudocode in the way which we can understand, and then we can go for algorithm, because in algorithm we have to follow the certain rules. As a pseudocode is easy to understand, so the structure of the algorithm also will be clearly visible. Here we are not following any rules, that's why we can modify it also. These are the some of the advantages. But what are the disadvantages of the pseudocode? It is not a visual tool like a flowchart, because in flowchart we use some symbols, so it is easy to understand. There are no proper standard for it, so it can vary from one programmer to another programmer, because the way programmer wants, he or she can write it. What is the third disadvantage? As we are writing it on the paper, there is no proper program available for it. It's an informal representation of the algorithm. So let's try to understand how to write the pseudocode for any program. I have taken one simple example, that adding two numbers. We have studied how to write the algorithm and how to draw the flowchart for it also. Now let's understand how to write the pseudocode. There is no proper standard for it. You can even write in your own local language, but we are following English as we are studying in English. So let's write the pseudocode. So here also first we need to take the two numbers. So we can write input first number, and I can take any variable in A. So similarly take another number, input second number in B. Now we have to add the two numbers. So directly also I can write this statement, C is equals to A plus B. Now after adding we have to print the output. So I can write print the result in C, or we can use display command also. So I will use simple print C. So this is the way you can write the pseudocode. It's very simple. There are no rules to write the pseudocode. It's an informal way of writing the solution for any problem. Let's take one more example, that we have to find out the larger of two numbers. Obviously the first step will be input, so we have to take two numbers. So input first number, again in the same way I am writing input first number in A, input second number in B. Now we have to check that A is greater than B or not. So if A is greater than B, we can write, then we have to display the message A is greater. So we can write again that print statement, or you can use display also. If this statement is false, we have to write the else statement also. If this is false, then we can write B is larger. So in this way we can write any pseudocode. It's very easy to write the steps, then you can go for an algorithm, then you can draw the flowchart. After writing the algorithm, we have to verify whether it is giving the correct output or not. For that we can go for dry run. What is the dry run? It's the process of manually working out through the code, and we have to check the effect of each line on the value of the variable. What are the characteristics of dry run? We can carry out dry run during the different stages of the problem solving. We can do during design, implementation, testing, or in maintenance stage also. It is used to identify the errors in a code. We can fix some logical errors. We cannot find any execution error using dry run when we are verifying the algorithm to ensure that it is working the way we want. We use the concept of dry run. During dry run, we maintain a table. It is known as trace table. Trace table displays the effect of each line of the algorithm on the value of that variable. So let's try to do the dry run and show its values in the trace table. Let's look at the simple code here and try to work out on the values in the trace table. There are two variables. One is num, so I have written num here. There is one more variable, result, so I have written here, and we are printing the value of the result. So we'll see what values we will get. The value of the num variable starting with 1 and going till 3. So the value of the num variable will be 1, 2 and 3. When the value of the variable num is 1, let's come inside the loop. So what we are calculating here, we are multiplying the variable num with 2, or we can say we are making it double. So initially the value of variable num is 1 and 1 into 2 will be 2. So that we are printing also, we will get the answer 2. In the next iteration, the value of the num will be 2 and num into 2 means 2 into 2 will be 4, and in the next step we are printing the result also. So we will get this answer. Again in the next iteration, the value of the num will be 3. So 3 into 2 will be 6, and we are printing the result also. So you can dry run any code and try to find out whether you are getting the correct answer or not. Let's try to solve one problem from your textbook. Here we have one algorithm, and from the corresponding trace table we have to find out the value of E, and we can take the correct option. There are two variables in this algorithm. First is n, so we have written here n. Then we have to consider the value of I also, so we have written I, and we are printing the result of n also. So here I have used the print statement. In the trace table you can even write the line number so that easily you can find out the values of the variable in that particular line. So let's try dry run and find out the values in the trace table. Look at the line number 1. So this is line number 1. The value of n is equals to 3. So we have mentioned here 3. Now come to the next statement, line number 2. In line number 2 we are printing the value of n. So we have printed here 3. Look at the line number 3. In this line the value of I will vary from 1 to 3. But in the beginning the value of I will be 1. So in the line number 3 we have written the value of I as 1. Okay, if it is true we have to come inside the loop. In the line number 4 we are adding 5 to the value of n, and the initial value of n we know it is 3 as we have initialized here. So 3 plus 5 will be 8. So in line number 4 we got the value of n as 8. In line number 5 we are printing the value of n that we got 8 just now. So look at the trace table. In line number 5 we are getting 8. Now only 3, 4, 5 line number statements will get executed 2 more times because the value of I is 1. Next time the value of I will be 2 and the value of I will be 3. So once we have executed, now for the value of 2 and 3, again the line number 3, 4 and 5 will get executed. Okay, then look at the line number 3. Next time the value of I will be 2. So come to line number 3 again. The value of I is 2. It is true because it is less than 3. So we will come inside the loop. The value of n is getting incremented by 5. So the previous value of n we got 8. So 8 plus 5 should be 13. So look at the line number 4. we got 13 here correctly. Now we have to print the value of n, so we have to print 13 actually. So this is line number 5 and we are printing 13. So till now we are getting all the values perfectly. Now again this 3, 4, 5 will get executed for I is equals to 3. Okay, then come to the line number 3. Now the value of I will be 3. So look at the trace table. Now we should have the value of I 3. So you got the value of E, that is 3. So we got the correct answer here is 3. So in this way carefully you should look at the values, the statements, and you can easily find out the value of it. Try to solve more and more examples so that it will be easy for you to know how to dry run the program. The next topic is comparing algorithm. When we are trying to solve any problem, we may get many solutions for it. So how to find out which solution is efficient? So we have to consider these two factors. One is space-wise efficiency, that how much amount of space that algorithm is occupying. So we have to write the solution in such a way that it will not occupy more space. The second factor we have to keep in mind, that is time wise efficiency, means the time taken to write the algorithm should be less. So in this chapter we studied very interesting topic, that how to solve any problem, how to write an algorithm, how to draw flowchart, and how to write the pseudocode. We started our journey to the programming world. So let's continue it with the next chapter. In the next chapter we are going to study one very interesting, fascinating and very easy, simple programming language, that is Python. In the next video I am going to cover chapter 5, that is Python fundamentals. So till then keep studying. See you in the next video.